Welcome on this tutorial. Wish all you are well. In this tutorial, I'll discuss about different numerical problems on Norton's theorem, and I'll discuss solutions of those theorem step by step. Entering into the discussion, please subscribe. It will encourage me to upload more and more important tutorials. In this problem, we have to find out the current through 2 ohm resistance by using Norton's theorem. First, I need to draw Norton's equivalent circuit. Say our load resistance is 2 ohm, this is 2 ohm. The rest part consists of Norton's current and Norton's resistance. So, we need to find Norton's current and Norton's resistance. How we will calculate those? To find Norton's current, what we will do? We will disconnect load resistance and that path will be shorted. So this 2 ohm resistance will be disconnected and terminal A and B will be shorted. Now current through this shorted path is equals to Norton's current. So here the current through the shorted path AB is the Norton current. From this circuit we will calculate the value of IN. Now in the circuit we are considering different loops. Say this is the first loop, current is flowing I1, second loop I2 current is flowing, and third loop I3 current is flowing. Here I will use KVL in different loops. First loop consists of this 6 volt source and a resistance 4 ohm. So summation of potential drop at this resistance 4 ohm and this 6 volt will be 0. So what is the potential drop across this 4 ohm? I1 is flowing in downward direction, I2 is flowing in upward direction. Considering I1 is higher, so I1 minus I2 multiplied by 4, this is the potential drop across this 4 ohm resistance. In this loop another potential is 6. Summation of these two will be 0. Now see what is the polarity. When I1 minus I2 is flowing in downward direction, this will be positive, this will be negative. So say minus, plus, plus, minus. So these two are in series opposition. So if we consider one is positive, another one is negative. So 6 is positive and this potential is negative. So this is the first equation. See here. From the second loop there is a current source having 4 ampere current. So value of I2 is minus 4 ampere. Putting this value in this equation, I got I1 is minus 2.5 ampere. Next, from loop number 3. In this loop, two resistances are there, 4 ohm and 6 ohm. So potential drop across this 4 ohm and potential drop across this 6 ohm, summation of these two will be 0. Now what is the potential drop across 4 ohm? Through 4 ohm, I3 is flowing. So potential drop across 4 ohm is 4 into I3. Through this 6 ohm resistance, two currents are flowing, one from right to left which is I3, another one from left to right which is I2. Considering I3 is higher, so potential drop across this 6 ohm resistance is 6 into I3 minus I2. Now summation of these two is equal to 0. Now see what will be the polarity. Through 4 ohm resistance, current is flowing from left to right, so this is positive, this is negative. Through 6 ohm resistance, I3 minus I2 is flowing from right to left, so this is positive, this is negative. See here, positive, negative, positive, negative. So both potential drops are in series connection, so both will be positive. In this equation, similarly, I will put the value of I2 is minus 4 ampere. Putting this value in this equation, I got I3 is minus 2.4 ampere. Now I need the current through AB, the short circuit path current. So here I1 is flowing from A to B and I3 is flowing from B to A. So In, which I have indicated from A to B, will be I1 minus I3. Therefore In is equal to I1 minus I3. Putting this value, I1 is minus 2.5 and I3 is minus 2.4. Ultimately we got In is equal to minus 0.1 ampere. So this is Norton current. Now we have to find Norton resistance. To find Norton resistance, we will disconnect the load resistance and we will replace all the sources with their internal resistances. Here 2 ohm has been disconnected. The voltage source and current source are considering as ideal voltage source and current source. Internal resistance of ideal voltage source is 0. So 6 volt will be replaced by short circuit. Internal resistance of ideal current source is infinite. So this current source will be replaced by open circuit. Now this is the circuit to find Norton's resistance, which is the resistance between points A and B. Now we need to calculate value of Rn. Here we need to check which resistances are in parallel and which resistances are in series. If we face any difficulties to understand, then we may redraw the circuit. A is one point and B is another point. So we will start from A and we will finish at B. So from A, one path is 4 ohm and 6 ohm. Another path is through 4 ohm. So one path is 4 ohm and 6 ohm. Another path is through 4 ohm. And ultimately these two paths combines at point B. So from this circuit we can easily understand that 4 and 6 is in series and equivalent of this is parallel with this 4 ohm. So ultimately Rn is equal to 4 parallel of 4 plus 6 and ultimately we got 2.85 ohm. This is Rn. Next we will put the value of In and Rn in equivalent circuit and we will calculate the value of load current. In is minus 0.1 ampere, Rn is 2.85 ohm. As this is the current source, this current has been divided into two paths. One path is through this Rn, another path is through RL. So what will the value of IL? IL will be main current, that is In, multiplied by other arms resistance, that is Rn, divided by summation of both paths resistance. So IL will be minus 0.1 ohm into 2.85 divided by 2.85 plus 2 ohm. Ultimately we got IL is equal to minus 0.05 ampere. Here IL is in downward direction and we got the answer minus. So actually IL is flowing from down to upward direction. In this problem we need to find out current through load resistance 4 ohm, this one, by using Norton's theorem. So first we need to draw the equivalent circuit by keeping the load resistance 4 ohm as it is. The rest circuit will be changed to its equivalent circuit consisting of Norton's current and Norton's resistance. Now for calculating Norton's current, we will short the load resistance 4 ohm and current through this shorted path is the Norton current. So I will calculate Norton current from this circuit. This is the circuit. See here, because of the presence of this current source and this voltage source, a current will flow through this 8 ohm resistance. After this 8 ohm resistance, means at point A, it is having two paths. One is through 5 ohm resistance, another one is through short circuited path. As here there is a short circuited path, so this 5 ohm resistance will be totally bypassed, means full current will flow through shorted path. So we may redraw this circuit as this circuit. Now we will calculate In from this circuit. Now in this circuit I am using mesh analysis. Summation of all potentials in mesh number 2 is 0. Means potential drop across this 8 ohm, potential drop across this 8 ohm, potential drop across this 4 ohm and this 12 volt. Summation of all these are equal to 0. Now what is the potential across this 4 ohm? Here through this 4 ohm I2 is flowing from down to upward direction and I1 is flowing from upward to downward direction. So current flowing through this 4 ohm is I2 minus I1 into 4. Now I2 current is flowing through 8 ohm and this 8 ohm. So the total potential will be 16 into I2. In this loop another potential is 12 volt. Summation of these three is 0. Now what is the polarity? I2 minus I1 is flowing through this 4 ohm resistance in upward direction, so this is positive, this is negative. I2 is flowing from this 8 ohm, so this is positive, this is negative. From this 8 ohm, I2 is flowing from right to left, so this is positive, this is negative. So see here, negative, positive, next positive, negative, positive, negative, positive, negative. So if we consider 12 volt is positive, then all other three potentials are negative. So we may put plus or minus sign like this. 12 is positive, 16 I2 is negative, 4 I2 minus I1 is negative. So this is the equation. Now here from the first loop, see I1 current is flowing. This I1 is no doubt 2 ampere because a current source has been used here. So I1 is 2 ampere. Putting the value of I1 in this equation, I got I2 is 1 ampere. What is I2? I2 is that current which is flowing through this shorted path. So no doubt I2 is Norton current. So value of Norton current is 1 ampere. Now we have to find Norton resistance. So here what we will do? We will disconnect the load resistance and we will replace all the sources with their internal resistances. Here 2 ampere is the current source, so that will be replaced by its internal resistance. Its internal resistance is infinite, so it will be open circuit. In place of voltage 12 volt, it will be short circuit. So this is the circuit to find Norton resistance. How we will calculate this Norton resistance? Here we have to check which resistances are in series and which resistances are in parallel. So this is the point A, this is the point B. So we will start from A to B. At this point we got two paths. One is 8 ohm, 4 ohm and 8 ohm, and another path is through 5 ohm. So this 8 ohm, 4 ohm and 8 ohm, these three are in series, and equivalent of this series is in parallel with this 5 ohm. So ultimately the equivalent resistance Rn is equal to 5 parallel summation of 8, 4 and 8. Ultimately we got Rn is 4 ohm. Now at last, to find out the load current, we need to put the values of Norton's current and Norton's resistance in equivalent circuit. Norton current is 1 ampere, Norton resistance is 4 ohm. So what will the value of IL? IL will be source current multiplied by opposite paths resistance, that is 4 ohm, divided by total parallel paths resistance, that is 4 plus 4. So ultimately we got IL is equal to 1 multiplied by 4 divided by 4 plus 4, that is 0.5 ampere. So the 0.5 ampere is ultimate answer. Now in this problem we have to find out current through 4 ohm resistance using Norton's theorem. So first we need to draw the equivalent circuit. This is the load resistance 4 ohm. The rest path of the circuit has been converted into Norton's current and Norton's resistance. So I will calculate the value of Norton's current and Norton's resistance. To calculate the value of Norton's current, we will replace load resistance 4 ohm by short path. So see here, this 4 ohm has been replaced by short path. Now current flowing through this short path is Norton current. Now from this circuit, the voltage source is 8 volt. Due to this 8 volt, current will flow through this 2 ohm, a portion of the current will flow this 2 ohm, and it will reach at point A. While it will reach at point A, the current is having two paths. One is through this short circuit path, another one is through this 2 ohm, 2 ohm and 2 ohm. As it is having two paths, and among those two paths, one path is in shorted, so no doubt all the current from A will flow through this short circuit path. No current will flow through the series resistance of 2 ohm, 2 ohm and 2 ohm. So this circuit may be redrawn as this circuit. So from this circuit, now I will calculate Norton current, which is current flowing through path A, B. This is that circuit. To calculate IN, here again I have used mesh analysis. In first loop, current I1 is flowing. In second loop, current I2 is flowing. From first loop, the summation of potential drop across this 2 ohm resistance, this 2 ohm resistance and this 2 ohm resistance and this 8 volt will be equal to 0. Now what is potential across this 2 ohm? That is 2 multiplied by I1. What is potential across this 2 ohm? I1 is flowing in downward direction, I2 is flowing in upward direction. So potential drop across this 2 ohm is I1 minus I2 into 2. Through this 2 ohm, I1 is flowing. So potential drop across this 2 ohm is 2 into I1. And another potential is 8 volt. Summation of all these are equal to 0. Now, what will be the polarity? Through this 2 ohm, current is flowing from left to right. So this is positive, this is negative. Through this I1 minus I2 is flowing from up to down. So this is positive, this is negative. Through this current is flowing from right to left. So this is positive, this is negative. See here, this positive, negative, positive, negative, positive, negative, and this one is negative, positive. So if we consider 8 volt as positive, all others will be negative. So putting that polarity, this one is negative, this one is negative, this one is negative, this one is positive. So this is that equation, and after simplification we got 3I1 minus I2 is 4. This is the first equation. Now from second mesh, potential drop across this 2 ohm, potential drop across this 2 ohm and potential drop across this 2 ohm. Summation of all these three are 0. Potential drop across this 2 ohm is I2 multiplied by this 2. Potential drop across this 2 ohm is again I2 multiplied by 2. Potential drop across this 2 ohm, I2 is flowing in upward direction and I1 is flowing in downward direction. Considering I2 is higher than I1, so potential drop across this 2 ohm is 2 into I2 minus I1. Summation of all these three are equal to 0. Now what will be the polarity? I2 is flowing from left to right, so this is positive, this is negative. In this 2 ohm, I2 is flowing from right to left, so this is positive, this is negative. Through this 2 ohm, I2 minus I1 is flowing from bottom to top, so this is positive, this is negative. So polarity say plus minus plus minus plus minus, so all are in series combination. So taking all are positive. So from this is the equation. From this equation, after simplifying, I got I1 is equal to 3 of I2. Now solving this equation 1 and equation 2, I found I2 is equal to 0.5 ampere. Now what is I2? I2 is that current which is flowing through this shorted path. So no doubt I2 is Norton current. So value of Norton current is 0.5 ampere. Now we have to find Norton resistance. To find Norton resistance, what you need to do? We will disconnect load resistance and we will replace all sources with their internal resistances. So we have replaced this 4 ohm, see here, and we have replaced this 8 volt supply with the shorted path. Now the resistance between the points A and B is Norton resistance. So I will calculate the Norton resistance from this circuit. Now to calculate the Norton resistance, first we need to check which resistances are in series and which resistances are in parallel. If we feel any difficulties, we will redraw the circuit. I am redrawing the circuit. Starting from A, 2 paths, one is at left side, another one is at right side. Left side started with 2 ohm. After this 2 ohm, again 2 paths. One is 2 ohm, another one is 2 ohm. This 2 ohm is in seriously connected with this 2. After this 2 ohm resistance, it is connected with another leg of this 2 ohm resistance. So these two are shorted. After this, another 2 ohm resistance which is seriously connected to reach the point B. Now from right side of this point A, this 2 ohm, 2 ohm, 2 ohm all are in seriously connected, and it will ultimately reach to point B. Now from this figure, it is too much easy to calculate the equivalent resistance. This 2 and 2, that is 4, which is in parallel with this 2, see here, that is in series with this 2 and 2, that is 4, see here. The equivalent of this is in parallel with this 2 plus 2 plus 2, that is 6. So ultimately this is 4 parallel 2, which is in series with 4, and equivalent of this is in parallel with 6. And after the calculation, I got Rn is 2.82 ohm. Now at last we need to put value of In, which is 0.5 ampere, and Rn, which is 2.82 ohm, in equivalent circuit. And from this equivalent circuit we have to calculate IL. So similarly, what will be the value of IL? IL will be the main current 0.5 multiplied by opposite path's resistance, that is 2.82, divided by summation of two parallel paths, that is 2.82 plus 4. Ultimately we got IL is equal to 0.206 ampere. So this is final answer. In this circuit we have to calculate current through 8 ohm resistance by using Norton theorem. So first we need to draw equivalent circuit. This is In, this is Rn, and this is the load resistance. Next we need to calculate value of In and Rn. To find the Norton current, we need to disconnect the load resistance and the path will be shorted. So 8 ohm is disconnected and it is shorted. Now the current flowing through this shorted path is equal to Norton current. Now from here, say only one source is here, that is 200 volt. From this 200 volt is current is flowing through this 2 ohm. After this 2 ohm, this point, this point, this point, this point, all at same point, means current will have 4 parallel paths. This is one path, this is another path, this is another path, this is another path. Among these 4 paths, this path is having no resistance, means this is shorted path. So no current will flow through this path, and this path. All the current which is flowing through this 2 ohm resistance will flow through the short circuit path. We may redraw this circuit as this below circuit. So I will calculate Norton current from this circuit. Now what is the value of this current? In this circuit only a single voltage source and only a single resistance in series. So the current will be this voltage divided by this resistance, means 200 divided by 2, that is 100 ampere. So this is Norton current. Next I will calculate Norton resistance. To calculate Norton resistance, we will disconnect this load resistance and we will replace all the sources with its internal resistances. So this 8 ohm resistance has been disconnected and this 200 volt source has been replaced and it is shorted. Now the resistance in between points A and B is Norton resistance. Now we need to calculate Norton resistance from this circuit. This is the circuit. In this place it looks like a H bridge. From this type of circuit, it is easier to calculate the equivalent resistance by using star delta conversion. I am changing this delta portion, that is A, B and C, with its corresponding star combination, and it will come like this. This is A, this is B and this is C. This 10 ohm, 20 ohm and 10 ohm, this was like delta structure. This delta structure has been converted into star structure, 5 ohm, 5 ohm and 2.5 ohm. Now how to convert from this delta to star? I am explaining a little about that. Now say this is delta to star conversion. The delta is having this blue colored R3, R1 and R2, and corresponding star is combination of this small R1, R2 and R3. See here how the name has been given. Opposite side of this R1 is small r1, opposite side of this r3 is small r3, opposite side of this r2 is small r2. So what will the value of R1, R2 and R3 in star structure? R1 is equal to product of two attached resistance. Which one is attached? This R1 is attached with this R3 and R2. So R1 is equal to R3 R2 divided by summation of these three R1, R2 and R3. So R1 is equal to R2 R3 divided by R1 plus R2 plus R3. Next, what will be R2? R2 is equal to product of these two divided by summation of 3. So R2 is equal to R1 R3 divided by R1 plus R2 plus R3. What will be the value of R2? What will be the value of R3? R3 will be R1 into R2 divided by R1 plus R2 plus R3. So using this formula, I have calculated delta structure to star structure. Say this is R1, this is R2, this is R3. So what will be the value of R1? R1 is equal to product of attached two resistance, that is 20 into 10, that is 200, divided by summation of all three in delta structure. So 20 plus 10 plus 10, that is 40. So R1 is 5 ohm. See here, 5 ohm. What will the value of R2? R2 is equal to product of attached two resistances, that is 20 into 10, that is 200, divided by summation of those three. This is 5 ohm. Say this is 5 ohm. What is R3? This is R3. Product of attached two, this is 10 and 10. So 100 divided by total is equal to 2.5 ohm. So this delta has been converted to star, 5 ohm, 5 ohm and 2.5 ohm. Now it will be easier to calculate the equivalent resistance from this circuit. Say this is that circuit. How to calculate Norton resistance from here? Again we have to check which resistances are series and which resistances are in parallel. We will start from A. A is having 4 parallel paths to reach point B. This is one path through this 6 ohm, this is one path through this 6 ohm, this is another path through this 4 ohm, this is another path through this 2 ohm, and ultimately it is connected at point B. So which one are parallel and which one are series? See, this 6 and 5 is in parallel with this 6 and 5. So first 6 and 5, 11 is in parallel with this 6 and 5. So 11 and 11 are in parallel. Next, parallel combination of this is in series with this 2.5 ohm. Equivalent of this full combination is in parallel with this 4 ohm. Equivalent of this full combination is in parallel with this 2 ohm. So ultimately this is Rn. After calculating this part, I got Rn is equal to 8 by 7 ohm. Now at last we have to put the value of In and Rn. In is 100 ampere, Rn is 1.14 ohm, which is 8 by 7. And for this equivalent circuit, I will calculate IL. This is the load current through that 8 ohm resistance. What will the value of IL? IL will be equal to source current, that is 100 ampere, multiplied by opposite paths resistance, that is 1.14, divided by 8 plus 1.14. Ultimately we got the current is 12.5 ampere. So this is final answer. Here I have explained 4 numbers of numericals on Norton's theorem. I found solution of those with stepwise explanation. I believe you will be able to solve different types of circuits by using Norton's theorem. In next tutorial, I will explain solution of more numericals related with Norton's theorem. Please subscribe, put your comments and queries in comment section.